All right, so we're starting 3.2 quadrilaterals. So from our prefix right here, quad means four. And for this part right here, we're going to think sides. So quadrilateral shapes with four sides. Now, we're going to first start off with classifying these. And so the first 8 problems on here are your 8 different types of quadrilaterals. Okay, so we're going to go through the first 8 are going to be different. Each one's going to be different. And then the next set of 8 is going to be just a mix. So those first 8 are really your notes. So make sure you're following along on these. All right, so let's look at number 1. Now, number 1, I see there are 4 sides. But it's just kind of a random conglomeration of sides. They don't tell me anything about how long the sides are, those little markings or anything about the angles. It's just a random shape with 4 sides. So as specific as I can be is just to call it a quadrilateral. Okay, that is as generic as I can be with 4 sides, but unfortunately for this one, that's as specific as I can be. So quadrilateral. Let's look at this one. Now this one, I see it has 2 pairs of congruent sides, but they're not opposite each other, they're connected. All right, so I have 2 that are the same length. They're together on both sides, 2 pairs. We call this shape a kite. So there's a kite. A kite has 2 congruent sides, but touching up against each other. Now, it not necessarily has right angles or anything like that. Doesn't tell me anything about the angles. Just tells me 2 pairs of congruent sides and they're touching each other. All right. This one, I see this one has a pair of parallel sides. So 1 pair of parallel sides, and we call this a trapezoid. We'll spend a lot of time talking about those later on in this chapter, I think on Friday. Number 4, I see a pair of parallel sides. Well, I just saw that on the trapezoid. The only difference is here, I have these 2 other sides, we call them the legs, are the same length, all right? And so we call this an isosceles trapezoid. So remember with triangles, isosceles means 2 of the legs are the same length. For a trapezoid, well, same deal. 2 of the legs are the same length, and it's a trapezoid because the bases are parallel. Okay, now this one is a little odd. We have 2 sets of parallel lines. These are parallel and these are parallel. And so when I have sets of parallel lines, and I don't know anything about the angles or anything else, we call it a parallelogram. Okay. Now, if you're looking at that thing, it kind of looks like a rectangle, then yes, a rectangle actually is a parallelogram. A square is actually a parallelogram. But this one right here, we don't know that they're right angles, which is why I don't know that it's a rectangle. So, parallelogram. All right, number 6. I have all 4 sides are the same. Now you might be looking at this thing, oh, a square has all 4 sides the same. And that's true. And we're going to get that in a second. But a square has to have 90-degree angles. So this is a shape that has all 4 sides the same length, but it doesn't care what the angles are. So this shape is a rhombus. Rhombus has all 4 sides the same, but we don't care about what the angles are. All right, now we get pairs of sides opposite each other are congruent, and all 4 angles are also right angles, and so this one is a rectangle. Get to some more obvious ones. And then lastly, probably our easiest one, all 4 sides are the same, meaning this is actually a rhombus, but more specific than a rhombus, more specific than a parallelogram. I see, oh, all 4 sides are the same, all 4 angles are 90 degrees, so it is a square. All right, so those are your 8 different shapes. So now what you're going to do, there we go, is starting at 9, 9, 10, 11, 12, 13, 14, 15, 16, stopping at 16. They're all just mixed together. Some of them might be duplicates. You're going to come up with the most precise name for each of those 8 problems. Okay, so 1 through 8 I gave you, those are your different types, and then use those names to answer 9 through 16. All right. And then that brings us up to this one. All right, so we're talking about interior angles. And for a quadrilateral, pen out, my interior angles, or interior sum, because we're going to add them all together, equals 360 degrees. Okay, so remember a triangle, all 3 added to make 180. When I add a side, I go bump that up to 360. And you'll find that for every side you add, you come back to, you just add another 180 degrees to it. But anyway, we'll get into those later. For right now, everything is going to add to make 360 degrees. So for my problem right here, we'll say, okay, they all are supposed to add to make 180 degrees. So let's add them. We have 88, 85, 95, plus question mark. You can put an X there if you want, or you can just leave it a question mark. I'll think, okay, well, let's add these together and subtract from 180. Pull my calculator out. So 88 plus 85 plus 95 gives me 280. Oh, I've already messed up. 268. I just wrote 360 here, and that's what I was supposed to write right there. So let me fix that. Sorry. 360. 360. It's about to get a negative angle. All right, there we go. Now subtract. So 360 degrees minus 268, and I get 92 degrees. So my question mark is 92 degrees. All right, that's number 17. Do the same thing for numbers 18 and 19. 18 and 19 are the same way. In fact, if you just want to pause the video, you can go ahead and do 18 and 19. Now, for 20, we're going to do pretty much the same thing, but instead of asking me just what's the question mark, we got through some X's in here, and we're figuring out what is angle D. What is angle D? So start off the same way. 360 degrees equals this one plus this one this one, and lastly, this one. All right, so have a lot of terms here. Let's start off with those X's. 14 plus 16 is 30, plus 15 is 45x. And then -1 and 4 make +3, plus 2 makes 5, plus 85 makes 90. Trying to get the x by itself, so I'm going to subtract 90 from both sides. And so that gives me 270 equals 45 times x. Divide both sides by 45. I get x equals 270 divided by 45. I'll make a mistake. 270 divided by 45. 6. All right. Now, if it just said solve for x, which is going to in a little bit, I would be done. But it doesn't say just solve for x. It says find the measure of angle D. Well, angle D is this one right here. So I need to take the number 6 and plug it in for that. Okay. So over here, 14 times 6 minus 1. Right? 14 times 6 minus 1, 83. And so 83 degrees angle D. So go ahead and try those. Number 20, numbers 21 and 22, same way. All right, 23. We're going to do exactly the same way. The only difference is here, my instructions tell me here, solve for x. So this time, I'm actually going to stop a step short of the last one I did. I'm just solving for x. Now, I'm going to set this up as 360 equals all three added together. Now, there are boxes. So that's 90 plus 90 plus 90 plus -1 plus 13x. Now, you might very well be looking at that like, wait, couldn't I just say that equals 90 since all my boxes equal 90? That one has to equal 92. Yes, you could. And that would be much faster. But I'm trying to show a method that's going to work for all the problems, not just this one. So that's why I'm doing it the longer way. But yes, you definitely could. If you see that they're all 90 degrees, just say that one has to equal 90 degrees as well. All right. So 90 plus 90 plus 90, that's 270 minus 1. So that gives me 360 equals 269 plus 13x. Minus 269 from both sides. $360 minus 269, 91. So 91 divided by 13, and I get 7. X equals 7, and that's my answer. And that's not 7 degrees, because to find out how many degrees it is, I'd have to plug it in. But they didn't ask me that. They just said, what is X? And so there it is. It's 7. All right, go ahead and try number 24, 25, and then put your name on your paper, put it in the top tray, and I'll get it when I come back. Thanks.